Good morning and welcome to the All Portable Discussion Zone, a biweekly podcast focused on amateur radio portable operations, QRP, homebrewing, and everything in between. My name is Charlie. FCC call sign is November Juliet 7 Victor, and I am your host. If you enjoy the show, you can find us on all major podcast platforms as well as YouTube and Discord. And we'd love to hear from you in any of those platforms. You'll find the links to those platforms along with resources and items mentioned in today's episode in the show notes. And joining me today is our guest, Dan, AI6XG. Dan, welcome to the All Portable Discussion Zone.
Thank you. Glad to be here.
Yeah. Dan, I think I knew of you and we had kind of a awareness of each other in Discord and just other, I guess, electronic areas. We didn't meet in person until 4 days in May, I believe. Is that right?
I believe so, yeah. A lot of
Yeah.
activity on Slack and Discord, and then
Yeah.
can see each other eyeball to eyeball, and
Yeah.
also chasing each other too on
Is
the
it?
SOTA peaks.
Yep. I think that's where I first became aware of you is the SOTA community. And then I quickly learned that you are quite proficient in electronics, and so that's what we'll be talking today is some of your projects. But I personally don't know a lot about your background, and so I'd like to start off by just asking you a little bit about your education, career, and other interests further on back in your life when you were a little younger.
I am a lot older now, so it's a long history. So I'll just keep it really, really short.
Sure.
And I grew up in Wisconsin in the Midwest and went to school at Wisconsin, and my undergraduate degree is in applied math and physics. And I worked in the semiconductor industry as my career. So I
Okay.
was really fortunate to get into it when it was growing really quickly. It was exciting and really exposed me to a lot of different things. And it was just fun. So I basically made the chips that you use when you're networking. And also, if you're on the phone, there's still a lot of copper and chips used in the background. And those, if your phone is working, then you can thank me because it's still working.
So you lived in Silicon Valley then?
So I live in near Sacramento, a suburb of just east of Sacramento. So all the people that are in the Bay Area that drive up to Tahoe to do SOTA, when you're on Highway 80, route exit 100, just give me a wave and I'll wave back as you go up.
So
So
you've been in that area a long time then, huh?
yeah, um, boy, since 1989, so
Okay.
quite a while.
Yeah. Cool. All right. And then what about your family life? What can you share about that? Anything?
Yeah, I'm married. We have no children, but we've been married for over 27 years now, and we met. We're both from Wisconsin, grew up in Wisconsin, but we met in California. And
Wow.
there was a little common ground there with the Midwest, being brought up in the Midwest, and so we've been married for a little over 27 years now.
Great. Great. And does your wife how does she feel about all of your little hobbies and things that you do?
Oh, she's fine with it,
Yeah.
but
Good.
she's got her share of hobbies also. So
Oh, great.
yeah,
Great. That's what's fair is fair, right?
absolutely, absolutely.
Cool. All right. Well, when and how did you get involved in amateur radio and electronics? And we kind of know about electronics, but tell us a little bit about kind of your journey that way.
I've always been interested in electricity. My dad was an electrician, so he didn't know much about electronics, but I always was interested in electricity. And in, man, it must have been seventh grade, I think, my uncle gave me a Helicrafters S38 shortwave receiver. And I hooked it up and threw a wire up in the tree and drilled a hole through the side of the house so I could bring in the cable.
Oh,
And
you drilled a hole in the house.
oh, it's okay. It's fine. And that's really started my shortwave listening and interest in electronics because I wanted to know how the radio actually worked. And that eventually, and I still have the S38. I've rebuilt it a couple times, but I still have it because it's something really special that started my interest in shortwave listening, which graduated into ham radio, in amateur radio. So I got my novice license when I was in high school, so probably around 1973. And then through college, after college, I got my advanced license. And as my career came and more things with life came and other interests came up, I actually let my license lapse in the late 80s. And it was in the 2010s, I was actually still a hobby of mine is gardening. And I decided that I really need to figure out how to measure how much moisture is in the soil and how deep it's getting and really regulate it. So I got back into electronics and started building some sensors for that. And I was at a makers fair in 2017 in the Bay Area, and I happened to come across a booth where there was a ham radio club providing exams. So I thought, I used to be a ham. Maybe I should see if I can do this. So I paid my $15 and took the exams and got my ticket back again in 2017.
Oh, great. And what was so? A couple follow-up questions. Your what was your call sign before you let it lapse? Do you remember?
Whiskey Bravo 9 Tango Charlie uniform with
Okay.
advanced license. And my novice license was Whiskey November 9 Juliet Hotel Zulu, a really bad call sign
Yeah.
for Morse code.
Yeah. Yeah. A lot of dits and daws in that one.
Exactly. Yes. But
Yeah.
that you really you couldn't change call signs back then very easily, if I remember. And
Yeah.
as a high school student, I wasn't going to pay the
No.
money to change call signs anyway.
Right. Right. Yeah. Who cared? Okay. Now further back, you said that you kind of got started with shortwave listening, and I've always found that fascinating. I even didn't even know it existed until much later in my life, and I hear quite often. I think some of these some ham radio operators get involved using through the shortwave listening. Um, I understand that it's kind of died out and it's really difficult now. Most of the shortwave listening stations are kind of not there anymore. But what do you remember about shortwave listening? Any memories come to mind?
Oh, it was really great. It was a way to really learn about other countries and other cultures. So back then, of course, there was no internet. So the way that countries extended out to other cultures and other folks was through shortwave, and you could really learn a lot about the countries. And then, of course, there was a lot of propaganda. If it was from Radio Havana,
Yeah,
Cuba, or
yeah,
Radio Moscow, that was a lot of propaganda, which you knew, but it was still interesting to follow them. So I was able to pick up stations from all over the world. And what you would do is you would tune into the program, and quite often there's programs that were weekly that I would tune in, and you would send a letter to them saying, I listened on this particular date and time, and this is what the content was. Then they would send you a QSL card back. So it was
cool.
always fun to go to the mailbox and see something from South Africa or from Czechoslovakia or wherever, acknowledging that you listened to the broadcasts.
Yeah, that's
And
great.
I talked my seventh grade science teacher into giving me extra credit every time I got a QSL card. He would give me extra credit for
Oh,
that because
that's
he thought it
great.
was pretty fun too. But very different now. Most of the stations out there are either maybe very extreme on type of maybe religious or political or just talk. So it's not as interesting as before because
Yeah,
now with the internet, you can, everybody's so tied together so closely that you don't need the shortwave radio anymore.
yeah, yeah. And so you got back into ham radio in 2017, you said. And if I remember right, Summits on the Air started in the United States in 2012, somewhere around there. I think I got started in it in 2014. So at some point, I mean, you got involved in ham radio. There was a time where you were doing just ham radio stuff, I guess, with your ticket, and then you got to the point where you discovered portable operations. What? Tell us about that gap, and then after that, let's talk about some soda.
Sure. So I got my ticket, and tell you the truth, it was just a spur of a moment thing to do. So I got my ticket, and I didn't really know what to do with it again. So every QST that came in, I read cover to cover, just trying to get up to speed after 30 years not being in the hobby, 20 to 30 years. And somehow I found out about SOTA. And I was already hiking, enjoying hiking up in the mountains. And fortunately, where I live, it's about an hour 20 up to Donner Lake and Donner Summit and up in the Sierras. So it's really easy access to the mountains. And when I learned about SOTA, it's like, okay, this is perfect. This is exactly what I want to do because I already enjoy going out hiking, and this will push me into other areas that I've not explored yet, as far as the mountains and then just the electronics. So I bought a KX2 and put together some antennas, and um, that started the SOTA experience.
Okay, so sounds like you got your ticket and you really didn't do a whole lot other of things in ham radio other than just diving right into SOTA. You maybe just a little bit here and there, but it sounds like you really got going when you hit this, got your SOTA interest going.
That really did. I think without SOTA, I'm not sure I would be as active as I am in ham radio. I think initially I set up a random wire, just a few, like 12 feet off the ground in my backyard, and did a little FT8 and just listening around. But then SOTA was like, okay, this is going to be exciting. This is what I want to do.
Yeah, and back then, I mean, at that point, 2017, you didn't need a to know Morse code. Did you know Morse code or not at that?
Oh, yeah. So when I got my novice license, of course, you had to learn 5 words per minute. And then to get my advanced license, that was 13 words per minute. And to get my advanced ticket, I had to go down to the FCC office. I was living in Dallas at the time, so I drove down to the Dallas office, and you had to listen and take a test and show them that you're proficient in code. So, it's like like riding a bike. You remember it, but after so many years, well, what happened is I got my advanced ticket, and I put my key away, and I just went on single sideband. So I really was not a CW operator after I got my advanced ticket. And so in 2018, I think was my first SOTA activation. My first couple of activations, I did okay. I had to maybe slow down to like 13 or 14 words per minute, but the exchanges I did okay. But I really knew that I needed to get my CW Morse code much better. So I signed up for CW Ops,
Okay.
and that was a really great way of going forward with my Morse code. The difference is when I learned it back in my teens, I wrote down every character on paper. I didn't do head copy. And really back then you just memorized, or there wasn't a real good way of learning. You could sometimes buy like a record album that had Morse code, but you just had to get on the air and just learn. And that's how I learned, was just writing down the characters. And CW Ops, I had to relearn Morse code through head copy. And that's a great step. So it it's like learning another language. You have to practice at it, and you know that, Charlie, pretty well. But I think CW Ops, and I know Long Island CW Club does a great job too. So don't be afraid of learning Morse code later in life. It's something that does come, and really for SOTA, for POTA, the exchanges are so standard that you it's much easier to do CW that way than it is just getting on the air and trying to write you. So don't
Yeah.
be afraid about doing it, and learn it the right way. Go to CW Ops or Long Island CW, learn how to head copy, and do it with the 20 word per minute characters with the spacing, and then decrease the spacing.
Yeah, cool. Well, it sounds like you dove in right away with CW though on SOTA, which is um, really advantageous. It took me a year. When I first discovered SOTA, I was a sideband only guy, and people kept, annoyingly encouraging me to learn Morse code, and I finally did, but it took a while. So I think the first year of SOTA was all sideband, 100% or FM. But then eventually, yeah, I learned the Morse code, and now, I mean, as you know, Morse code is I love it, and you do too, I think.
Sure. Yeah.
Yeah,
Well, my goat was all HFCW, so
yeah.
I haven't done any single sideband, and I did some 2 meter FM, but I would always activate the summit first using CW. But I had the advantage that I already knew Morse code from a kid. And it's
Yeah.
like when you get on a bike again, it's a little rusty, but after a while you get back into it. And CW ops really helped me get get to be a little better bike rider
Yeah. Yeah.
than
Good.
I was when I first began. So I did have that advantage. So I never went through single sideband. I have nothing against the other modes. I just enjoy CW. And one advantage is the radios are just simpler and smaller and more efficient. And the transmission, the mode itself is so efficient with power that it works really well.
Yeah. So you got into SOTA, which is great. I love Summits on the Air as well. So let's talk a little bit about. So you said initially you got a KX2 or three, and you spun up
Yeah.
a TX2, and you spun up a Homebrew antenna, and kind of got your station working. And I know that that whatever you started with, it's almost impossible for you to have kept that the whole time and stayed with that equipment. So what equipment are you using now? And maybe let's talk a little bit about what's your favorite equipment is and maybe some enhancements that you've made to your station over the time.
So my SOTA station.
Yeah, yeah,
Yeah. So there's a lot of really good radios out there. So just because I have a preference doesn't mean it's the only radios. But I think there's two that I use most of the time. The MTR3B LCD, so the Blue Series, any of the MTR3B Blue Series is a great radio. CW only, but the form factor is so small. And then the battery I use with is just a small RC battery, so it's really compact.
how many amp hours?
350 milliamp hours.
Oh, it's a really small one. Yeah,
Yeah, so you can see it's just this guy right here.
yeah, yeah. I have a 450, which is about the same size, maybe a little bigger.
And I take two with me on every activation. I've never had to use the second one. The first one's always been more than enough, even on 2 or 3 summit days. It still
Yeah,
works really well.
that's awesome.
The so the other radio that I like is it's the tribander that I modified. It's from a Steve Weber design, and I just like that because it's not as small as the MTR3B. It's 40, 20, and 15, so it's a really nice match to a 40-meter end-fed half wave. So the antenna is resonant on each band. But I did a lot of modifications on, put a lot of work into it. So it's always fun to use a radio that either you built or did a lot of modification on. So I get a
Yeah,
lot of satisfaction out of that.
yeah. We'll be talking more about that one, I'm sure, huh?
Yes, I hope so a little later. And as far as antennas, with the MTR3B, I use a trapped 30, 20, 30, 40 end-fed half wave. And then with the tribander, I use a 40-meter end-fed half wave. So it's resonant on 40, 20, and 15, which is the bands that I chose for the tribander.
Yeah,
And I really started that project with the tribander when the sunspots were increasing or near the peak. And I really wanted a radio that of course, I could use the KX2, but I thought it'd be fun to build one that you could do 40, 20, and then 15. You have that
for sure.
extended band. And I like having antennas that are resonant for the bands that you're going to operate on, because that way you don't have to get up and change links or change antennas, or you don't have to have an antenna tuner.
Yeah, for sure. Funny you say that. As age is advancing on me, I'm getting more and more annoyed with having to get up and change those darn links. And so, a trapped dipole would be great. Now you said that you did this is a little off topic, but didn't you do some studies or research on kind of the effectiveness of the trap? And there was something you did and you posted in the Discord channel about traps, I guess, just traps. Or was that something else?
Well, a lot of work, I've done a lot of work on the transformer, the on. So the 49-to-1 and 64-to-1. A lot of work on the efficiencies and the right winding configuration for it, the most efficient way to wind it, and just how to measure the efficiency of the transformer. And measuring the transformer loss, if you want to do it in a very quantitative way, is pretty difficult because the measurements you're taking is the entire loss, and then you're subtracting out the mismatch loss and the loss in the load. And those are three really big numbers. And the difference between those numbers is very, very small, and that's the loss in the transformer. So any very small deviation in those big numbers has a big impact on that really small quantity that you want to actually measure as a loss. So there's a lot of steps that you have to do to make sure your measurements are very accurate and
Yeah.
precise to do it.
Yeah,
So
that's what it was.
that's a lot of the work that I've been doing.
Yeah,
Traps,
it wasn't traps, or was it traps?
it was is the antenna, the
Yeah.
transformers, the
Transformers,
anode.
yeah.
Yeah.
Yeah. But the traps, you've done some, you've actually made them, right? You've made some
Oh
some traps.
yes, yeah. The traps I've made, and then N7KOM has a nice trap kit that you can buy, and then he references my NFED trapped NFED for 20, 30, 40 as far as what kind of lengths that you need for it. But yeah, I did a lot of work on the traps.
Yeah.
I haven't. That's one thing I would like to do is do a little more study as far as the efficiency of the traps. And the question is always, do you want the trap to be within the band that you're trying to trap, or do you want it outside or the band that you're trying to use? And it's really a hard thing to measure quantitatively. There's a lot of conjecture as far as where it should be, and pretty good modeling that's been done that argues that it should be just outside the band. But I would like to do something that's a little more quantitative and experimental, but I'm not sure right now how to actually go forward on that.
Yeah. Well, the traps, I've had some struggles with traps because they're kind of delicate, aren't they, as far as getting them just right. And so I don't know, but
Yeah.
I guess we need to back up just a minute and explain what traps are to maybe somebody who's a little newer to ham radio.
Oh yeah.
Maybe you can take a shot at that instead of me.
Yeah, absolutely. So the transfer we're talking about is a parallel inductor and capacitor. And when that trap or the inductor and capacitor are resonant, it's a very high impedance, a super high impedance in parallel. So what you're doing is using that to actually, it's almost like a link where instead of getting up and having a mechanical link, you have a electrical link that isolates different segments of the antenna. And that way you can use that antenna on different bands that you ordinarily would not be able to when it's resonant.
Yep.
So think of it as an electrical version of a mechanical link.
That's a great way to put it. Yep. Cool.
But
Okay.
there is a lot of interaction, so you're absolutely right. Getting all the segment lengths right is a bad.
So yeah, we had a internet down issue, and so yeah, Dan's up back, and it looks like his video is good. It's on his backup. It's fancy. You have two different options, so yeah, we're looking good. All right, so welcome back, everybody. Let's go ahead and continue. We were talking about traps, weren't we?
Or yes,
Or we were just wrapping up the discussion. You were saying something about how I was saying they were hard, and then you had a thought on that.
right. The hard part is when you're using the traps for in an antenna and then getting all the when you're setting the antenna up and getting all the segment lengths right, there's some interaction between the two because it's not a perfect isolating switch. So that can be hard to actually set the antenna up. But once you got it, it's really worth it.
Yeah. Good. Okay, now let's move on. I got one more soda question for you, and then we're going to get into the good stuff, the some of the homebrew stuff in the project. So, that question is just your philosophy on SOTA, because some people, I mean, everybody's journey in SOTA, I think, changes over time, and even people start for different reasons and they end and do different things in different ways. And so, in particular, I wanted to see what your philosophy is. What does soda mean to you as far as why you're involved?
Well, it's provided a lot of motivation to do some projects, to make some antennas and experiment. but I think just learning and finding new friends. So getting to know you, Red, and getting to know other people, whether it's the same chaser you have on a lot of activations, and then you finally be able to meet them eyeball at FDIM or at Hamvention or at Pacificon is really, really fun. But for me, the hike is the fun part of it. Not saying that the radio contact isn't fun, but I it's taken me to summits I would never go to otherwise. And when I was hiking, I would just stay on trails. Now I bushwhack to summits. When I travel somewhere, I'm always searching out for summits. So that's something that's really nice for me for with SOTA is just getting me to other places I would ordinarily not hike to, and I meet new people that I would not have had a friendship with as well.
Yeah, I think my philosophy is very similar to yours. I do it for the social aspect as well, and then just for the motivation to get out there and see new things. And man, I'm probably like you. I've seen more of Arizona than I think I ever would have dreamed in my entire life. I mean, I've been places that there's just no way I would have went had it not been for that summit that I wanted to get the points on. So yeah,
Yeah, it's fun when you go to some of these summits and you look at the register and nobody's been in the register for like 4 or 5 years because why
right.
else would anybody come up to that summit unless you're some of those crazy people on Peak Bagger that just do summits because they're
Oh,
there.
right, all the
But
time. Yeah.
exactly, exactly. And thank goodness for them because quite often they're the ones that give you an idea of the best approach for it. So, social aspect, I do a lot of my summits activations by myself. That doesn't mean I don't enjoy joint activations. I really enjoy having other people with me, and I like to see how they do it compared to how I do an activation, and we can learn from each other. And it's just nice to have company out there at times.
Yeah, well, and social doesn't need to be in-person social because I mean, a lot of times I'll be out in the middle of nowhere, very remote by myself, and it gives me comfort to know that I have people that are going to be on the other end of my radio that I can talk to, and stuff. So it doesn't mean in-person social for sure.
Yeah, exactly.
Okay, so let's go ahead and shift gears a little bit. I'm really interested in some of your projects and your experimentation and stuff like that. I asked you ahead of time when I asked you for the interview to kind of give us a little guided tour of your web page. So maybe if you have an opportunity to pull that up, and you showed me one other page too. Did you want to start there or with the one I showed you?
I'll go ahead and start with my webpage
Yeah, cool.
from the blogs and go and step through it. And I'll share. And I'm sure we'll have a URL for everybody in the comments, but it's pretty simple. It's just mycall.com. So Alpha India 6 X-ray golf.com. And I've got various different areas of posts. And what we're looking at is the making and hacking, which is under the electronics. And there's quite a few different projects here. One lately that has a lot of interest is the 40 to 10 meter QMX. And basically what I did there was I took a high band QMX. Well, first of all, I'll start off. QMX is from QRP Labs. It's a great multi-band small radio. And but it's either a high band, which is 20 through 10, or low band, which is, I believe, 40 through 80, or maybe a little higher than 20 through 80. And then there's a mid band, but I modified a high band so that you could use the QMX from 40 meters to 10 meters, which I think is almost a perfect SOTA rig because when it's hooked to a 40-meter NFET half wave, you can operate on 40, 20, 15, and 10 and get your local QSOs and also hopefully some DX on 15 and 10 meters. So I went through and did some modifications there. And you can go ahead and take a look at it if you're interested. The best way to do it is before you build the kit, make the modifications. I did actually after I built the kit, but the best thing to do is do it before you make the kit.
So So for the real quick on the QMX, so there's a it comes as a what 20, 17, 15. Is it a four bands or is it five with
It's
up the upper?
20, let's see here. Maybe I have it in my write up here.
Because I think it's like, yeah, 20 to 10. Is that what it is?
It's
Oh, there we go.
20 through 10, including 11 meters if you want to get on CB. So in fact, down here on the bottom here is 27, 17, 15, 12, 11, and 10 is the original configuration.
So
So what I did,
it's five bander originally and
six bander.
six bander. And you did you drop one of the, how did you, real just very high level, how did you drop one of the bands and add one or how?
Yes, I sacrifice 11 meters.
Oh, I see. Okay.
And then I may have the final configuration down here. Sorry to go through so quickly, but let's see if I have the final. Here's the final configuration. So in the final configuration, it's 20, 17, 15, 12, and then 40 and 10.
I see.
It's a little out of order, but I just substituted 40 for the 11-meter slot.
Good. That's very interesting. I have to read up on that. Is it possible to give a very high level of how many, like what's involved in that?
Sure. So basically what you're doing is two things. One, the major thing is modifying the bandpass filters that that you had in there so that you could also get on 40 meters. And if I remember right, I'm sharing 40 and 20 meters in one bandpass filter or low pass filter. I'm sorry, low pass filter for the output. So you have to do some measurements, make sure that there is enough second harmonic attenuation with that modified low pass filter on 40 meters. And then, so that's the modification I made on the low pass filter. And then there is a bandpass filter in the receiver, which is pretty wide band, but you do have to make a modification so that your sensitivity on 40 meters is good. But if you're starting with a kit, you basically just substitute parts rather than having to do a modification to the circuit
Oh, that's nice.
on there. So if you haven't built the kit, then it's fairly easy to do this modification. The thing that you have to do is just make sure that the low pass filter for 40 meters is sufficient to that you're meeting FCC requirements for the second harmonic,
Okay.
which in most cases do. And then you have to go in and modify the software, but Hans set that up pretty easily that you can log into the radio and make changes in your configuration. So what I'm showing right here with the different bands, it's just a putty serial connection into the radio, and I've just changed the bandpass filter configurations. And that's the great thing about the QMX is that you can make these modifications and change the software. You have access to that, and then you can also test this. Hans put some self-tests in there that aren't, he even says aren't super accurate, but they at least give you an idea if you're on the right page.
That's really neat. That's amazing. That's fun. I have an unbuilt upper higher band QMX, so this would be a good project for me.
Absolutely, absolutely. And I've gotten a lot of feedback. A lot of people have done this and really enjoy operating the radio that way. Especially we still got 10 meters does still open up at times
Yeah.
and you still want to get your friends that are close in on 40 meters.
Yep.
So the other project that I really enjoy doing, and I use the radio quite a bit, is the KD1JV Steve Weber tribander. And this is a kit that you can choose which bands you want with the kit. And so I chose 40, 20, and 15 because I knew that this is when the sunspots were at the peak. I wanted a 15-meter operation, And then by using a 40 meter end-fed half wave, it's resonant 40, 15, 20, and 15. So it's a perfect match to the antenna. And I actually have the finished unit here, if people can see. And
That's cool.
and it's very nice. I use this rig quite often. I either use the MTR3B or this rig for most of my activations.
Is this kit still available for people to buy?
I'm not sure. I checked last night and it said it was out of stock.
I
So
see.
I've heard rumors that it may be discontinued, but hopefully it's just out of stock and we can continue. Maybe if there's enough interest through this video, maybe they'll decide to bring it back into stock.
Right.
So let me just show you what the actual radio looks like. And I'm on a little slower connection now, so things are coming up a little slow. I apologize for that, but at least we're back on the air. So this right here is the way that the kit is intended to be built. So it's a large metal case. It's got some kind of funky band selection there. It's just something that's not really good for portable operation carrying up to the summit. And so I decided that I wanted to put into a configuration that I like. And that's something that I do when I start a project is figure out what are the things I want to accomplish. And I'll list what are my needs, the things that must be accomplished in the project, and then some would be some what ifs, that some wants that would be really, really nice to have. So here I list a few of them. I just don't like the heavy and bulky metal case. The receive consumption, current consumption is pretty high. It's 90 milliamps. And there is some reasons for that. And when I operate on a summit, I like to have everything flat. I didn't like the way that there was the LEDs and the controls are off to the side, which is great, I think, if you're operating at home or your base station. But most of the time on the summit, I'm sitting on the ground. I like to have the KX2 and the MTR3B LCD and everything is facing up so you can operate a little better. And just the way the band changing was. And I knew that the LED display was not going to be very good in the full sun. So I did this in stages. In the first stage, I made changes for everything except for the LED display because I knew changing over to eliminating the display and changing to an LCD was going to be a lot of work. So I thought, okay, let's get some of these other things done first, make sure it works pretty well, and then take that second step to put the LCD in. I think that's really important when you're looking at a project is to split it up into smaller chunks. And that way, it's much easier to make sure that each of the sub blocks work well and you can put things together. And sometimes these projects can take a while, and it's nice to have a stage where, okay, it's going to work, let's try it for a while. And then if you want to make some changes, you can do that in the second version. And that's exactly what I did here.
Yeah, I like that you're systematic with this. So it sounds like you have some sort of a list that you follow, and uh, the first one being that you evaluate, and before you even do anything, you evaluate and make a list of wants, like you said, and things you want changed. And the next one is to systematically kind of do phases, which is also a really good idea. So
Right. And this showed it, I took what I liked about the radio and then what I didn't, and I wanted to change the elements that I did not like. And this is a great radio as it is for people that want to do QRP, probably at their home or base station, or even maybe POTA on a picnic table. But for me on the summit, it just didn't work out the way that I wanted to.
right.
So the first version was this, where I still had the LED display. And what this did was I was able to go through, and the one thing I added, a major thing, was there's relays in the original version that switches the bands. It changes the band pass filters and the low pass filters. And those were conventional relays, which when they're switched on, consume a lot of current. And that's why the receive current was so high at 90 milliamps. So I switched to a latching relay. And that way, the current that you need to keep there's no current required. There's only current during the switching of the relay itself. So it's a very short 3 to 4 milliseconds of current. Then after that, the relay is latched in place and you don't need to have continuous current to hold the relay in place. So that was a big portion of this. So the first thing I did was determine if I was able to actually use these latching relays to make the band changes that I needed to for the radio to use. So that's the first step. And that took a lot of work, which I built instead of just doing this printed circuit board in the beginning. First thing I did was just build a perf board version of this with the latching relays and the microcontroller, make sure that I was able to switch the relays and that it actually worked with the radio and switched the bands the right way. And I always do that prototype before I commit to a printed circuit board. And I think that's another important thing because it never works on the first time. There's always things that you need to change, and especially if you're doing some software through, whether it's through a microcontroller or whatever. So that was the first step. And just everything else, almost everything else was very similar to the original kit. But
So
this at least let me make sure that the switching and the band switching all worked before I committed to more work.
yeah, so you breadboarded this. I see the green board. You breadboarded the what's on the green board then first to make sure it worked,
Right.
and you probably went through several iterations and changes before you finally got what you needed. Then you took you must have developed some sort of perf board and sent it off to be printed, right?
Right. Then I just went into KiCad and built the printed circuit board. Now, the actually the hard part, another hard part about this was being able to match the printed circuit board so it will actually connect into the original kit, the original tribander.
I
And
bet.
fortunately, when they laid it out, and in my write-up, I talk a lot about how the bands are switched and the relays work. We won't go into that right now, but there is various steps I went through. But this picture right here, which if I click on it, I think it will get bigger. And because I'm on a slower internet now, it's a little slow. But I use a perf board, and these are the relay positions on the original board, and also some other. So that way, I could use that to mechanically lay out the printed circuit board because I need to make sure everything connected on the original tribander board.
So
So
for
that green,
those So for those listening, basically you got a green board with a perf board, and then there's like pins coming out in various directions.
and that, and these are all zero point 0.1 inch spacing, standard 0.1 inch spacing. So that gave me the mechanical spacing for all the different sockets for the relays as well as the LED display. And I think here was the keyer, the paddle input. And
Okay.
there's a few others over there. So there's a lot of different stages that come in, not only on a printed circuit board is not only electrical, but also mechanical so that everything fits together. But
Uh,
fortunately, everything was laid out. Now, I remember a previous episode, you were talking with Adam and Tobias about perf boards. And this is a perf board I like. You can get through Amazon. It's got nice vias that are plated all the way through. These are all solder plated. And the printed circuit board material itself seems to be pretty good through HF at least. And they're very easy to solder to. And the the older the other type of perf board that's kind of like brown in color and has the copper islands,
yes, I have those.
those work those work fine except I find that those copper islands tend to lit if you have to change a component out once or
Oh,
twice.
okay.
These are these are really easy to solder to, and seems like you can. I've removed and replaced components a number of times, and these little islands, conductive islands, are really strong and work out pretty well. But anyway, so this is just an example. I worked on this circuit and the microcontroller first to make sure I had everything working. So I actually was sitting there with a perf board on the tribander and making sure that it operated just like it normally would, but with my modifications with the latching relays.
That's neat.
So it worked. I made the printed circuit board. I did a couple activations, but you know what? This LED was just really hard to read in full sunlight. And most of the activations I do are in full sun. So that's when I decided to take the next step. I already knew that most of it was working, and that was to change out from an LED display to an LCD display. So once again, I evaluated, I used it. It was a first step with with that LED display. But I figured out there's just some things I didn't like about it. The way that I did the headphone connection. And with the LEDs, there's menu modes like receive, increment, tuning, and actually putting in messages and setting the CW speed. And the LED symbols were really cryptic for those menu modes. And I just didn't like that. And with the 4 digits of the LED, there was no megahertz digits. So like if you're on 40 meters, you only got the 0.030
Oh,
megahertz. You didn't get the 7.030. So I wanted to change that. And as it turns out, this kit has a software error where you cannot calibrate the digital signal generator that sets basically the mix of frequency that you're on. So you're always off by 1 or 2 kilohertz.
oops.
So fortunately, people that chased me with the LED version were able to compensate. They tuned around, able to find me. But if I'm changing the readout, there may be a way to actually put an offset in there so that the readout is actually what frequency you're on. And again, I like the LCD to read in full sunlight. So once again, I looked at what I wanted to do in this particular project and evaluated what would be the hardest part about it. And what I felt the hardest part would be is finding the LCD that I wanted to use. I really like the LCD that's on the MTR3B, the Blue Series LCD. You can see in the sun really well. It's easy to read and it's a really small size. And it took me a while, but I finally found which LCD is used for that. So that was the first point. And that was really a deciding factor whether I could go on with the project. And there's always those factors. In the first version, the factor whether the project would be successful was whether I could get those latching relays to work. In this one, it was the LCD, finding the right LCD and then being able to address it. And so I put it together and it works, and I've been using it since, and it works fine. But I like to go through there and just showing the steps I took. This is a layout of the whole project, and I already had the latching relays working and the software, so I didn't have to do any work on that. The next step was decoding the LED segments. Now, I didn't have access to the microcontroller that was on the original kit board. So what I had to do was actually take the digits and the segments that were being sent to the LED and use those to translate into something that could be written on LCD. So I had to do a little bit of work on figuring out what the digit timing and the segments were and doing some voltage translations. But I wanted to do that first to make sure that it actually worked. And once I went through that, I felt that I could go through the next steps. And that took a while, but once I had my prototype, and again I had a prototype, I just had a microcontroller and that LCD and wires into the LED signals and showed that it worked. And then I was able to do the menu item decode. So an example is here, the receive increment tuning. And you can see here, I read out what the offset is and also RIT on the LCD. On the LED, the original display, all you would see is the 0.5 and this funny little R
Yeah.
type symbol that for RIT. But here I was able to translate the menu items into exactly what they are, so you could read it off. And like here, when you're exactly on, it show that the transmit and receive frequencies are together. And on the LED display, you would get this funny little thing that was supposed to look like an equal sign, but you weren't quite sure what it was. And then, so I got that working. And then the next step was displaying the frequency. And there it was a little different because I wanted to come out with an actual number, and then I could subtract or add that offset for that error, the software error in the original kit. So that was the next step, and I was able to do that. And then I had to figure out how to write this to the LCD. And the LCD is a serial interface. So I had to figure out that interface. And then the next step, this was a want rather than a need, is working on the LCD backlight. So I decided that I would put a dimmer in so I could either have the LCD with no backlight or different dimness on brightness on the backlight. And what originally I had one microcontroller that was controlling those latching relays as well as converting the LED digits and segments to what I could write to the LCD. And when I tried to use that same microcontroller to control the dimming on the backlight, it just didn't work out. There was like a lot of flashes because the microcontroller was doing other things rather than just doing the dimming. And I'm not real good at coding, so I'm sure there's a workaround. But what I did is I just added another microcontroller. So there's a real small microcontroller here that I use just for the dimming.
Okay. Works.
And when you do your projects, you can make that decision. If you're doing this as a commercial product, you probably wouldn't do that because it adds to the cost and all that. But this is your own project, so that was the easiest thing for me to do, was just have a separate microcontroller that was doing the dimming by itself. And that's the nice thing about the projects. When you do it, you can make your own decisions. And
Yeah.
and if it didn't work, it was fine. It wasn't something that I absolutely needed. And then I made some changes to the headphone jack and audio gain. So this is just, I just wanted to go through a little more detail than probably you wanted to see, but just wanted to show that there's a lot of different steps I went into. And I made sure that once the first block worked before I went on to the next block.
Yeah.
And that way, at the end, you can put everything together and have a lot of confidence that these projects work. And likely, if you try to do everything at once, it probably wouldn't work and would make it much harder to figure out what went wrong.
Yeah. Good advice. Good advice
It's
for
something we'll. And I did the same. And the other thing that's really important is just documenting. And each step I documented. And I think Adam was talking about that. Sometimes on these projects, you come up to a challenge and you just don't know what to do. And you may decide to step away for a couple of weeks even, or a couple of days. And by documenting things, then you can come back and actually pick it up where you were, or actually go back and think about it a little bit more. And I found that when you're starting to write this up and doing some documentation, that's when the idea will come. Oh, I bet you this is what I did wrong. I bet you I can fix it this way. It takes a little bit of discipline, but it works out pretty well. And there, I use OneNote for that. And OneNote's great because you can put in, you can write, you can draw, you can bring in photos, you can bring in PDFs, you can bring in anything you need on that.
OneNote. Yeah.
So that's that project, and it's worked out, and I enjoy using the radio
And
as well.
what's your next goal? Do you have one
My next goal for another
for
project,
for this project? Is it done?
I, I think it's done. You know, for me, there's no case, and that's okay because most of the summits I'm on are it's pretty good environment where it's pretty dry and stuff like that. I think this particular radio probably in the way it is right now probably wouldn't be good up in Washington or Oregon where they get a
Yeah,
lot of rain and moisture, and you would need to expand on that. But for me, it's good enough. It works just fine right there, and I enjoy using the radio. And part of the enjoyment is because you built it yourself.
great.
So you've looked at the page. Is there anything else you would another project somebody like me to take a look
Um,
at or talk about?
well, that one was really cool. I know that you already gave a presentation in 4 Days in May about the tube project, and so people can go look there for that. Let's see. I don't know. I mean, there's so many fun things. Let's just choose one more maybe that we wanted to. What, do you have another one in mind that, of your projects you think would be great we can talk about?
Um, oh, there's all kinds. Maybe, well, if people want to look at something that's a little different, this how I killed a microcontroller is actually not a project, but it's a full analysis of a project that I built and it failed. And I went through the circuit, why it failed, and then I actually went down and opened the integrated circuit up and showed on chip where it failed and how it failed on chip. So it's a little different from most other projects here. Might be an interesting read for somebody that's interested in that. And one of the things I'm working on right now is a very similar project that I'm hoping that I'll be posting here sometime in the future, like that.
Good. Let's see. What about this don't fear the Smith chart? That seems like might be something good for our beginners, people that aren't so into homebrew yet and are trying to get in.
Sure. So I think a Smith chart is actually pretty challenging no matter how experienced you are. And a lot of that is because when you read about Smith's chart, there's a lot of math and it just tries to confuse you, or it's just really hard. So what I did in this write-up is just talk about a little bit of the math, but explain why a Smith chart is actually circular. And that's a fun part of it. And just explain in simple terms what a Smith chart is. And a Smith chart is you're not plotting impedances or frequencies, but you're actually plotting what's called a reflection coefficient, which is when you have a transmission line and matching how much of your forward power is actually reflected, and that reflective coefficient defines that.
Yeah.
And I go through and just talk about that, and it's actually pretty easy to use a Smith chart to build a simple matching network. And the reason I did this particular in-depth investigation is because I built a 17-meter QCX, which is a real small single band radio, and I wanted to use it with my 20, 30, 40 trapped end-fed half wave. So I decided to do that. I would have to build a matching network of some type. And as it turns out, a Smith chart is a really easy way of doing it. There is a great piece of software. It was originally called SimSmith. It's now SimNEC, which is by AI6XG Ward. It does a great job of supporting that software, and you don't have to actually sit as at a Smith chart. You can do all the simulation using that software. So basically, this walks you through how Smith chart works. It looks complicated, but if you follow it, it's actually pretty easy. And I use that to build an LC network. Let's go down to this one example. And what I did is I measured what the impedance was at 17 meters for that antenna that I wanted to match to. And then I use the Smith chart, or actually use SimSmith to do the match so that it goes down to a very small, a very good match to 50 ohms. And this is the SWR chart right here for the match. The blue is before I put some potting on the match on the actual circuit, and then the red is afterwards. So I'm less than 1.3 SWR on 17 meters using the antenna, and this is the matching network right here. So this is a pretty simple project to build, especially beginning. It's just a few capacitors and an inductor and on a perf board. But the key is you can learn more about matching networks and Smith charts by doing it.
Oh, great. Yeah, this you have so much good information on this website. There's no way we're going to be able to cover it all. In fact, I'm looking at the time, and it's we're getting there. So I just would encourage people to reach out and take a look at the website and see what you like. There's a bunch of projects there. Plus, there's also, as I mentioned, Dan gave a really good presentation at 4 Days in May. If you go over to the 4 Days in May YouTube channel, you can find him. It was just last year. It was the title was something along the lines of building a radio over the several generations or over time. Or you remember what what the title was? Something like that. Through
Yes, it was a journey through time or something like that. But
yeah,
uh, oh, I forgot what exactly. It was a brilliant title, but I can't remember what it was. But
yeah.
basically, what I did is build a tube transmitter that could be used for SOTA activations. But I use technology from the 1930s to current 2020s,
Yeah, it was really a
and
fascinating
every
presentation.
every every decade.
Yeah, every decade there was some sort of technology that he included in this radio, and and there was a tube in it, and all kinds of good stuff. So that's a good presentation. Check that out. Um, Before we end, I wanted to ask you a little bit more about just home brewing philosophy. You mentioned, when you have a project you want to do, you want to make sure you evaluate it and determine the wants and needs and the things that you want to work on. That was one thing. You also mentioned that you should take it in steps and don't do it all at once. Do you have any other homebrew advice as far as steps that you should take in doing projects?
Well, do it for fun.
Okay.
I always seem to have a reason to do these projects. The like the tube one, there was really no reason to do it except it just seemed like a really fun thing to do. So make it fun. And there's other people out there. There's a lot of advice, whether it's on YouTube or internet or just through Slack or through Google Groups. There's a lot of other people out there that can help you with it. So
Yeah.
don't be afraid to do it. And if you're beginning, just do some simple projects or put together kits. And especially some of the kits like from QRP Labs, Hans does a really great job of documenting not only how to put the kit together, but how the circuit works and maybe some of the decisions that he made on how he did the layout and such. So start out small, and I've been putting stuff together since I was a teenager, and so it was something that really made me really interested in electronics and kept me motivated and made me want to learn about new things. So my initial kits or initial projects were with tubes, but then I went right into transistors and integrated circuits back in the late 70s, mid 70s when I was doing this as a kid.
Yeah,
And really most of my engineering knowledge came from ham radio and putting things together, but really understanding how these things work. So it's fun to do, and don't be intimidated by doing it. Do something that either copy somebody else's design that's simple, or do a simple kit.
perfect. Great. Okay, Dan, we'll kind of wrap it up there, but I wanted to give you an opportunity. Where can people find you? If you, do you have any place where you like to have people go? Is it your website? Is it on Slack? Is it email? Tell us a little bit about how to get a hold of you if people have questions about your projects or want to know more about things.
So my website is the first place to go, and there's a way to contact me through the website, and I try to respond. And then also I'm on Slack, the North America SOTA Slack channels.
Good.
I'm uh,
And
I'm involved in that pretty much too.
you're on the air, so set your ham alert for AI6XG, and you can talk to him that way too.
You might be I might be working you through some of these projects that I'm showing you right now.
Yeah. All right, Dan, we'll stick around after we wrap it up, and I'll talk to you for a few more minutes. But I really appreciate you being on. The whole point of this interview and some of the ones I've just recently done and that I may be doing in the future is to just get people like myself involved in ham radio homebrew, even though you're new at it. And I thought, I'm new at it, so let's just go on this journey together, and we'll get some really smart people like yourself on to learn more about homebrewing and start the journey. I'm very new to it, but I want to learn. And just like you pointed out, the main thing is you just got to dive in and pick a project, and as you go, you'll learn. So that's the
Yeah.
whole goal.
And you'll make mistakes and you'll blow things up and everything, but that's just part of the fun. It's okay.
Yeah. All right, Dan, thank you so much for being my guest today. Really appreciate it. We'll be catching you on Slack, I'm sure, and other places. Won't be at 4 Days in May this year. You going this year?
Yeah, unfortunately, I guess fortunately, we're taking a trip during that time, so I won't be there.
Yeah, neither me neither. So, well, maybe next year. But at any rate, all right, we'll catch you on the next one. And everybody who's listening, thank you so much for being here, and we will catch you on the next one. Bye bye, everybody.
Right, 72, everybody.